Welcome to my channel. We will be solving this past exam, and right now the exam I have for is May June 2025. Okay, you can see this here, and it is mathematics mechanics part 4 mechanics. Okay, so let's start the problem. Uh, so the question number 1. Okay, this is right here. Okay, this question was the statement of the question was a bit confusing. I was confused by this statement, line of greatest slope. I'm not sure why they're using this word. Okay, anyway, the scenario is that we have an inclined surface which is making an angle of 8 degree with the horizontal, and there's a box on this surface, and the weight of the box or mass of the box is 25 kilogram, and it is being pulled by a distance of 12 meter. The length of this ramp is 12 meter. Okay, so we have to pull this box from the bottom of the ramp to the top, and the total length it is going through is 15 meter. And this ramp is a rough surface, where that means there's a frictional force as well. So the frictional force, we are told that this is a force which is opposing the motion of the block, and that force is 50 Newton. Yes, it is 50 Newton. Okay, so question is find the work done by the pulling force. Okay, so I'm showing the frictional force, not the pulling force. I'm not so sure the pulling force. But yeah, anyway, you can understand that the force is being applied to make it go up. Okay, so this applied force or the applied work done is being used against three factors. One is that it has increased the potential energy. The potential energy of the box has increased, so the work done has been utilized in increasing the potential energy. This is number one. Second is that the initial speed of the box was zero, and when it reached the top, its speed became 2.4 meter per second. So, and when it reached at the top, it has some kinetic energy as well because of this motion. And thirdly, the work done is used against this frictional force as well. So there are three forces, three areas where this applied force or applied work done has been used. So first of all is the potential energy, and you know that potential energy is equal to mgh. I hope you have no problem with this formula. Okay, anyway, m is 25 kilogram, g is 9.8, but we can approximately use a 10, and height. Now, height is the perpendicular height. I hope you know this thing that height is not the 12-meter distance, but the vertical height. And that vertical height is going to be 12 into sine of 8 degree. I hope you have no problem about this thing. Okay, so the h is 12 sine 8. So if we calculate all these things, this comes out to be, uh, this is, okay, yes, it comes out to be 417.5 joules. Okay, now the second part is the kinetic energy. When it reached to the top, it has some speed. So the kinetic energy is half mv squared. So half, and m is 25 kilogram, and v is 2.4 meters per second is square. So this would be 12.5 times 2.4 and square. It gives us 72 joules. Okay. And the third is the frictional force. So that force time distance is the energy used in that working against the friction force. That force is given as 50 Newton, and the distance is 12 meter. So this is 600 joules. Okay. So the work done by the pulling force is equal to 417.5 plus 72 plus 600. So that comes out to be 1089.5 joules. Okay, so this question was pretty straightforward, but the way they wrote it, at least it sounds complicated or confusing to me. I don't know about you guys, but I'm confused by this word line of greatest slope. I don't know why they're talking about this in this way. Okay, anyway, so let's move on to the next question. Okay, um, this question is about momentum. Okay, we have a hammer whose mass is 1.5 kilogram, and it hits on this nail. Nail is 5 gram only. So a machine of for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.5 kilogram, and the mass of the nail is this one. Okay, the hammerhead hits the nail with a speed 32 meter per second and remain in contact with the nail after the impact. Calculate the speed with which the combined hammerhead and the nail move immediately after the impact. You see, immediately after the impact, the speed is maximum. After that, when the nail goes inside the wood, the speed becomes slower and slower. Anyway, so immediately after it, uh, I will use the law of conservation of momentum here. So the momentum of this hammerhead is 1.5 kilogram multiplied by its speed, which was 32 meter per second, right? Plus the mass of this nail is 0.005 kilogram and its speed was 0, right? Equals now the total momentum after the impact. Okay, so after the impact, the total mass is 1.5 kilogram plus 0.005 kilogram and whatever velocity, whatever speed it has. So from here, we conclude that this speed is going to be equal to 1.5 times 32 and divided by, when I add these two things, it will become 1.505. Okay, so when I did this calculation, our answer came out to be, let me do it again, 1.5 times 32 and divided by 1.505. So this comes out to be 31.89 3 by limited 4 8 meter per second. Okay, so this is the speed of the this combined thing after the impact. Okay, there is a constant force resisting the motion of magnitude 25,000 Newton. Yes, so that force is the when the nail entered the wooden block, so the resistance is that much. Okay, to the distance the nail is driven into it. Okay, so now what I will do, uh, um, you see the total energy, how much is the total energy? Okay, total kinetic energy. So the total kinetic energy is half mv squared, and that kinetic energy is being used to drive the nail into the wooden box. And the frictional force is 25,000 and into the distance it has traveled is d. Okay, so from here you can see that the distance it goes inside the wood, it is equal to 0.5 and mass was 25 kilogram and its speed was 32 meter per second. So this is 32 square. Okay, and Why am I saying 25? It is 15. 1.5, sorry. Yeah, I mixed up something. So this mass is 1.5, not 25. Okay. And divided by 25,000. So this comes out to be 32 square, 1.5, yes. So this comes out to be 0.03072 meter, which is 3.072 centimeter, and we can approximate it as 3.1 centimeter. Okay, so this was our part 2. Okay, now let's do question number 3 as well. A train travels for 4.8 kilometers between 2 points A and B. Okay, the train starts, rest, and accelerate, and then goes with the constant speed. Okay, uh, so let me draw the velocity time graph for this train. Okay, so this is time and this is velocity in meter per second, and this is time in seconds. Okay, so train travels from zero speed, so it was started from rest, right? And for initial, sometime it accelerates with a constant acceleration and reaches a speed of 30 meter per second. Okay, this is given over here. Okay, after that, it moves with a constant speed, right? And it goes with a constant speed for the time t. We do not know how much is this t. And after that time, it deaccelerates with a constant acceleration and stops at point B. Okay, so we know that this acceleration, okay, we don't know, yes. The only thing we know is that total, the speed, when it was constant speed, it was 30 meters per second. And we know that it ends at 180 second. Okay, the total travel time was 180 seconds, and the distance it has traveled is 4.8 kilometer. Okay, now we need to find in this problem we need to find the t, the time for which it was traveling with a constant speed. Okay, remember the total distance is the area under the curve of velocity time graph, right? We talked about it several times before. Okay, so let's try to find out the total area under this curve. Okay, so it consists of this rectangle, right? And these two triangles. Okay, now what about this rectangle? Okay, now, okay, yes, this total area is, how much is the total area? This is T, so it is T times 30. So this is the area of the rectangle plus. Now I have these two triangles, 1 and 2. So if I join them together, it becomes something like this, right? The highest point is 30, and this width, how much is this width? I hope you agree with me that this width is 180 minus t. Okay, so the area of this triangle is half, and 180 minus t into 30. And we know that this total area is equal to the distance traveled, and that is 4.8 kilometer, which is 4800 meters. Okay, I hope nobody have any problem with this expression. So we can solve this and find the value of t here. So you see this is 30t plus 15 times 180, it is 2700, and minus 15t equal 4800. So 30t minus 15t is 15t equals 4800 minus 2700, which comes out to be, okay, let's just do in the next step. So the t is 4800 minus 2700 divided by 15, and this comes out to be 140 seconds. Okay, so out of 180 second, 140 second, it was traveling with a constant speed. Okay, so this was this question. Okay, and the next part, yes, next part is that find the distance moved by the train while traveling at the constant speed. Okay, so this is easy. That distance is t times 30, so it is 140 times 30. So this comes out to be 4,200 meter, which is 4.2 kilometer. Okay, so this is that's it of this problem. Okay, so I will stop here and I will do the other next problem in the next slide. Thank you very much for watching. See you in the next video.